So today, and we're going to try to, and we'll see what time allows, but we're going to try to do all four of these so that you have a good understanding of how to write and graph functions for everyday situations, okay? So our first one says Micah works at a bakery. His specialty is donuts. He bakes 12 donuts on a tray. Write a function that describes the relationship between the number of donuts and the number of trays. Okay? So first of all, I would like us to underline that. The relationship is between the number of donuts and the number of trays. Those are our two things that are going to be changeable. One of them is going to represent our x, the other one's going to represent our y. So what are the two things in our relationship, first of all, so we have that underlined. And then another piece of information that seems pretty important in there is what? Hayden? He bakes 12 donuts on a tray. So that kind of seems like a constant. Every tray that he uses, he can get 12 donuts on it. He puts 12 donuts on it. So we're going to circle that. He bakes 12 donuts on a tray. So that's our constant. It does not change. He doesn't, on one tray, throw 12, and the next tray decide to only put 10, and the next tray 11, and then the next tray 5. Every single time he puts a tray together of donuts, he puts 12 on there. So let's finish that table that I have there. I am saying that the trays are in control. In other words, take a tray out, put 12 donuts on it, and what would the output be? So if there's one tray, what would the output be? 12, yeah. And if there's two trays, it would be 24, wouldn't it? And if there's three trays, 36. What are you doing every time there, Wade? You're coming up with this pretty quickly. What are you doing? Just adding 12 every time, because the trays are going up by 1, so the donuts should be going up by 12, right? And 4 trays would be 48 donuts. Okay. That's as far as we're going to go. I'm not saying that that's the most amount of trays of donuts that Micah's going to make. We're going to take that information now and we're going to write a function for it. What did I say yesterday is another word for function? Equation. So we're going to write an equation for this. So if x is the number of trays and y is the number of donuts, x is the input and y is the output. Write an equation on your paper, you think, on that line there, right here on this line. Write an equation that you think we could use to represent that table. On that line right there that I highlighted. Write an equation. Or in other words, remember you figure out the rule. What do we do to the x to get the y? What do we do to the input to get the output? And then that's how we set up our equation. Danny, you think you got one for us? Okay, you gotta say it louder for me. Okay, here's what Danny thinks it is. Y equals 12x. Everybody have that same one? Yeah, because what's happening in that? It says, take the x value times 12. Is taking times 12 the same as adding 12 all the time? In other words, can we shortcut it and say instead of adding 12 4 times, we can multiply 12 by 4? Right? Yeah. Instead of 12 plus 12 plus 12 plus 12, we could do 4 times 12. So y equals 12x is our function. Okay, then it says, well, if Micah makes 5 trays of donuts, how many donuts has he baked? We're going to use our function for this, okay? So let's go over here to the side and let's show that this is going to be our work for A. If Micah, so here's our equation. Here's what we think represents this relationship. So if Micah makes 5 trays, looks like we know which value, the x value or the y value. What is that 5? Is it the y or is it the x? We've got to make that decision always. Is that our x or is that our y? 5 trays. X. Everybody should be able to say that. I do not know why you're looking at me with that look of, I don't know what you're talking about, lady. So we're going to substitute 12 or 5 in for the x, so we're going to be taking that 5 times 12. Go ahead, find somewhere to multiply 5 by 12 or figure out what it is. 60. Or we could almost kind of go back to our table and say if we added 12 to 48, now we'd be at 5 trays, wouldn't we? So 60 is our answer, but 60 what? Donuts. So if he makes 5 trays of donuts, he'll end up with 60 donuts. Okay, part B. How many trays would Micah need to get 108 donuts? So part B, use our, hopefully you're not writing too big, like I kind of got a little carried away. It looks like I didn't leave myself much space. Here's our function, y equals 12x. What's the y and what's the x again? The y is representing what? What's y again? What's y in this situation? The number of, yeah, the output, the number of donuts. And x is the number of trays. What do we know? Do we know the number of donuts or the number of trays? We know the number of donuts, so where are we going to put that in our equation?
For the y.
For the y. Yeah, we have to substitute in for the y this time. What do we do to solve that equation? Divide by 12. You have to go on to the back side of the page or whatever you're going to go to, find somewhere to divide 108 by 12. Or remember the shortcut for when you're like, well, I don't know how many times it goes in there. Remember, we already know that 5 of these guys right here, those are 60. So we could just do this, couldn't we? Plus 12. No. What is that? 72. I'm going to come up here now. 72 plus 12, what's that? 84. Well, we're not there yet, are we? Plus 12? 96. Oh, we're not there yet. Plus 12? 8. And that's a 10. Oh, we finally got there. How many 12s do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. So apparently 108 divided by 12 is 9. 9 equals x. So our answer is 9 what? Trays. 9 trays. Okay, now I want, before I'm going to hand out the graphs handout because we're going to graph this next, but before we even do that, I want you to get out your calculator and would you, what if instead you stuck 108 in for the x, so that would mean you take 108 times 12, right? Okay, take 108 times 12. What is that? Harley, what is it? 1,296. Okay, so our answer would be 1,296 trays to make 108 donuts. Does that seem reasonable? No. I would hope that you would say to yourself, 1,296 trays? Wow, that's a lot of trays, first of all, isn't it? And every tray's got 12 donuts on it. So, but guess what? On a test, guess which answer would be in the answer bank? Along with 9, guess what the other answer would be? 1,296, because they're going to check to see if you just are happy to get an answer. They're always going to have that wrong answer in there for you. They're really smart about that. You see, you put these tests together. Okay, the next thing that we need to do is we're going to, I want us to graph this, okay? So let's go to number 1 on that new handout I just gave let's graph I have it all ready for us here, it looks like. This is donuts, and the X's are representing trays, the Y's are representing donuts. Why do you suppose I went by ones on the X-axis?
Because that's in trays.
Yeah, trays, they got one tray, two tray, that makes more sense. Why am I going by 12s on the Y-axis?
Because there are 12 donuts on each.
Yeah, because those are increasing by 12. So you know what this is, sometimes we just pick our scales according to that. So it actually also makes it quite easy to do what? Graph the points, right? Because once you start, if you're going one tray at a time and 12 donuts at a time, it just keeps climbing, one up, one over, doesn't it? One up, one over. Okay, now what I want to do is, we're going to draw a line through this, okay? Just because I only want you to graph those 4 points that were in our table, okay? Just 4 points that were in our table. And then what I want you to do with that ruler as a straight edge, I want you to start down in the corner at the origin, and I want you to draw a line, or actually it's going to be a ray. We're going to start down here at the corner, and where if there were 0 trays, we would have 0 donuts, and we're going to go, oopsie, what did I just do? And we're going to go through those 4 points and carry on past it. What am I still doing wrong here? Okay, try again. All the way through the graph. Like that. Make a ray. Has an end point, and it goes on forever in that direction, heading out of quadrant 1, I mean. It doesn't ever really go out of quadrant 1. This quadrant 1 actually goes on forever. Okay, now what we're going to do is we're going to go and we're going to find what the answer that we got for part A. What was part A about? Which point would that be on this graph? Ordered pair what? 5 what? 60. Okay, let's go plot ordered pair 5, 60. And let's put its name there. It should fall right on our line, shouldn't it? Because this is the line that shows the function y equals 12x. In fact, we're going to write that on here also. Y equals 12x is the equation of that line. Okay, what was our other answer? 9, 108. Okay, so let's go to 9 on the trays and 108 on the donuts. Over here is 108 on the donuts, and sure enough, there we are, right on the line. So we just verified that we have good answers for part A and part B. Okay, questions? Go on to number 2 then. Are we ready? Okay, let's go back to number 2. Read the problem to yourself, please. Underline the relationship. Circle the constant. Number 2, where we're at. Underline the relationship, circle the constant, and see if you can start filling out the table. And then, see if you can write an equation for this relationship. Write a function. Okay, share your equation with me. Share your equation with me. Wait.
Y equals 5 times x.
Okay, y equals 5 times x, also known as 5x, right? Can we write it that way? Okay. Everybody agree? Does it really matter? I'm just saying that this is how you would see it in an answer bank.
I know, I'm just.
But it doesn't really matter, no. Just gotta make sure that you know that they mean the same thing, is all. That's what I'm just trying to make sure we understand. Okay, well then let's start answering the questions. A, how far can Elijah ride in 2 hours? Harley? 10. It's in our table, isn't it? It's right here. How far can Elijah ride in 2 hours? 10 miles. Okay. Now it says, how many miles would Elijah travel if he rode his bike for 4 hours? Now, we don't have that in our table, and we're not going to extend our table. We're going to use our equation. So before you get ready to answer me, make sure that you have written the equation and subbed in for either x or for y. And then you can tell me what the answer is. Okay, Sam?
4 times
4 times 5. Okay, so you're saying that 4 goes in for the x. And that answer is 20. Okay, so it'd be 20 what? Y are the miles. And that's what they were asking us for, weren't they? So we have to make sure we know how to use our equation and we know how to use it properly. Okay, go graph it. And remember, we're only graphing the points that we had in our table. That's where we'll start with. Oh, this one's got a problem. What's its problem? Doesn't have the numbers on the side, on the y-axis, does it? What should we go by? 5s. Okay, good choice. And label it up, all the way up, before you do anything else. Take a look at your other sheet, because our answer for A on your line for y equals, by the way, we should put our equation up here again too, y equals 5x. Okay, so is the answer for A on our line. After 2 hours, he rides 10 miles. Is that on our line? Yep, okay, let's go put that by it to verify that we have a good answer, because it's on our line. Okay, and then what was the answer to B? What was that one about? What's the relationship going on in B? How many hours, how many miles? 4 and 20. So we'll go to 4 on the graph and up to 20. And sure enough, 420 is on our, well, at least it's on my line. Is it on yours? Yeah? Okay. So we verified that we had a good answer for part B also. So our graph represents it. Using our equation represents it. Different representations. Okay, now from the graph, using the graph to help you, I want you to tell me how many hours it's going to take to ride 45 miles. Using the graph to help you, how long is it going to take to ride 45 miles? Harley?
45 miles will take 9 hours.
Okay, how'd you get that, Harley?
5 times 9 is
No, not because 5 times 9. I want you to use the graph. Why is it 9 hours according to the graph?
So you go up on 9, you go straight up, it's 45.
Basically, I'm thinking that it might be actually a better idea to start at 45, since that's the number I gave you. Follow it over to the line until you land on the line, and then do what?
Oh, there.
Go down until you get down here to the hours, and it is 9 hours, right? Okay, so, but does the equation also verify that? 9 times 5 is 45, yeah. So when it says use your graph, though, that's what it's asking you to do. When it says use the graph. If it tells you use the equation, then we substitute into the equation for the x or the y, whichever one we need to. Okay, let's go to number 3 now then. Math tutoring. Get really good at math, folks, so that you can tutor others. Because math tutors get paid a lot more than $10 per hour. They get paid a lot of money. I don't know if you've ever had to hire one, but they get paid pretty good. I don't really understand why, but they do. So, Katerina gets paid $10 per hour for her math tutoring. She's giving him a good deal. Write a function that describes the relationship between how much she gets paid and how many hours she works, or in other words, how many hours she tutors. So again, we're going to say, here's what our relationship is about. These are the two unknowns. How much she gets paid total and how many hours she actually tutors. What is the thing that does not change in this problem? $10 per hour. So gets paid $10 per hour. That's a constant in this problem. It can't change. We don't sub in for that. So tell me, what do you think our equation would be? What would we have to do? Well, first of all, it looks like we got to decide what the x and the y's are going to be this time. So what would be in control here? What depends on what? Do the hours depend on the total pay? Or does the total pay depend on the hours? Total pay depends on the hours. So we're going to make the y value the total dollars. And the x value is going to be the number of hours. So what would we have to do to the input to get the output? What would we have to do to the number of hours to get the total pay? Kaden? Take it times 10. So what would our equation be then, class? Y equals 10x. Let's do this through 4 hours. 1, 2, 3, 4. If she tutors for 1 hour, how much money is she going to make? $10. If she tutors for 2 hours, $20. If she tutors for 3 hours, $30. If she tutors for 4 hours, $40. In other words, we just take the number of hours and do what with it? Multiply by 10. 10 times the x gives us the y. Okay, so it says, if Katerina earned $50 in a day, how many hours of tutoring did she do? So let's go over here and do our work for A, because we're not going to put it in our table. We're going to use our equation and get practice with that. Y equals 10x is our equation. Earned $50, how many hours? Where would that 50 go in? For the x or for the y? Earned $50, how many hours? Where should we put that 50 in? For the x or for the y? Sierra, what do you think? Okay, is it 50 hours? No, it's $50. So our x is hours, our y is dollars, so we're going to put it in for the y. What do we have to do to solve that? Divide by 10. 50 divided by 10 is 5. So our answer is 5 hours. Seems like a good answer, yes or no? Yeah, okay. How much does Katarina earn if she tutors for 3 hours? Class?
30.
$30. That one's in our table, isn't it? We have it there. Okay, let's go graph. I think on this next graph, I would give you even less. I said, you know what? You gotta learn how to set up a graph. There's the math tutoring graph. What's going to be the title on the x-axis? Hours, okay. So go a little bit below it so that you're going to be able to number the x-axis also. What do you suppose we should number the hours by? Ones, okay, an hour at a time. So go ahead and get those numbered. Number the hours. And we never number just the ones we want. There has to be, this is like a number line. A number line that is using a scale of 1. We can't jump over some of them and say, oh, I don't want that number, that 7 in there, and I don't want that 10 in there. I'm just going to put the others. Okay, how about the y-axis? What's its title going to be? Total dollars. Okay. So go. You get to turn your paper over to do it. What do you suppose we should pick for a scale for our y-axis? Tens. And once we pick it, every grid line has to represent $10. So we go up by tens, all the way to the top. So that if we want to use this graph, we don't have to count while we're doing it. And how many points do we have in our table? How many points do we have in our table? No, we didn't. I thought we had 3. Go back and look at the other sheet. Seriously, people. You are bums.
Thank you.
You're welcome. Kind of nice bums, though. How many? Did we have 3 or did we have 4? 4. Oh, we had 4. Okay. Then we'll plot 4 points. 1 hour, $10. 2 hours, $20. 3 hours, $30. And 4 hours, $40. Take your ruler and draw your ray.
That's not very good of a line tool.
I know, isn't it? Well, you not very good at a ruler. Okay. Now let's verify that we have good answers for A and B. What's going on in the relationship in part A? What did it say? For how many hours, how many dollars?
She would earn
$50, and we came up with 5 hours. Okay, so let's go plot 550 on our graph and give it its name. And if it landed on our line, we have a good answer. Okay, how about part B? How much she made for 3 hours. So we already have that point on there, so let's just go give it a label. 3, and it is 30. And is that what we said, $30? Okay, then we have good answers. Questions? Okay, then that means you're ready to do the last one totally on your own. Every part of it, go. The only thing I'm gonna set for you are, I'm gonna tell you how many, what to put it for the x's. That's all I'm gonna do, that part. Okay, this is yours. You gotta say what are the x's representing, what are the y's representing. Write an equation, fill out the table.